The first computer weighed 700 pounds and filled an entire room. Your smartphone has more computing power than NASA used to land on the moon. Today, we're tracing the incredible journey of computer history, from ancient counting tools to artificial intelligence, how key breakthroughs transformed society, and why understanding this evolution helps us grasp where technology is heading next. By the end of this episode, you'll see how every major computing milestone was driven by human needs and social pressures. Let me hand this over to someone who can really break down this fascinating timeline for us.
You know what's wild? According to Live Science, the history of computers is literally the history of the world. Every breakthrough we'll talk about reflects the social conditions and human needs of its time. And it all starts way earlier than most people think.
How early are we talking?
Well, the abacus dates back to at least 1100 BCE, according to Britannica, and it's still used today in Asia. But here's what's fascinating. In the 1570s, merchants and traders were using books called ready reckoners, filled with pre-calculated tables for things like compound interest.
Wait, so people were basically using printed spreadsheets in the 1500s?
Exactly. But here's the problem that would drive the next major breakthrough. These books were full of calculation errors. And that frustrated a guy named Charles Babbage so much that it motivated him to invent something better.
Ah, Charles Babbage, I've heard that name. Wasn't he called the father of the computer?
According to Wikipedia's list of computer science pioneers, yes. In 1822, Babbage designed his difference engine, and then in 1837, his analytical engine. And get this, the analytical engine had components he called a store for memory and a mill for operations.
Those sound like modern computer terms.
Right? And according to History Tools, it could be programmed using punch cards, an idea Babbage borrowed from the Jacquard loom. The crazy thing is, while the complete analytical engine was never built, his designs foreshadowed developments that wouldn't emerge for over a century.
So he basically invented the concept of the modern computer in the 1800s, but the technology wasn't there yet to build it?
Exactly. And we can't talk about early computing without mentioning Ada Lovelace, who some consider the first programmer. According to Live Science, she worked on Babbage's machines and made crucial contributions that often get overlooked.
It's interesting how many women pioneers get forgotten in tech history.
Absolutely. Speaking of which, here's a fun fact from the Computer History Museum. The term bug in computing comes from Grace Hopper. In 1947, she found an actual moth stuck in the Harvard Mark II computer and taped it into the logbook,
Right.
writing, "First actual case of bug being found underneath."
Wait, so computer bugs are literally named after an actual bug?
Well, the term was used earlier. Thomas Edison used bug to describe problems in his inventions as early as 1876. But Hopper's moth definitely popularized it in computing. And this brings us to the electronic era.
Right, so when did we move from mechanical to electronic computers?
The big moment was 1946 with ENIAC, the Electronic Numerical Integrator and Computer. According to the International Journal of Advancements in Technology, this marked a revolutionary moment, showcasing electronic computing for complex calculations.
And these early computers were massive, right?
Huge. According to research from Clemson University, the first computer created in 1822 by Babbage weighed 700 pounds. But even ENIAC was enormous, expensive, and primarily used for scientific and military purposes.
So how did we get from room-sized monsters to laptops?
The game changer was the transistor in 1947. According to Clemson University's research, this revolutionized computing by replacing bulky vacuum tubes with smaller, more reliable components. It led to rapid advancement, integrated circuits, microprocessors, and eventually personal computers.
That's incredible. So one invention basically enabled everything that followed?
Pretty much. And here's a striking comparison. Most laptops today weigh between 2 to 8 pounds, compared to those 700-pound early machines. But the real revolution came in the 1970s with the microprocessor.
The microprocessor, that's what made personal computers possible?
Exactly. According to the International Journal research, the 1970s microprocessor enabled smaller, more affordable computers. This led to PCs like the Altair 8800 and Apple II in the mid-1970s, making computing accessible to individuals and small businesses for the first time.
And that's when we started seeing computers in homes?
Right. According to Microsoft's documentation, the late 1970s and early 1980s saw the personal computer revolution really begin. The IBM PC in 1981 running MS-DOS set new standards, and iconic models like the Apple II and Commodore 64 brought computing into homes.
But weren't these early PCs still pretty difficult to use?
Oh, absolutely. According to Wikipedia, early personal computers were often sold as electronic kits and were mainly of interest to hobbyists and technicians. The real breakthrough for everyday users came with graphical interfaces.
Ah, so that's where Apple and Microsoft come in with their user-friendly interfaces?
Exactly. Microsoft's Windows 1 launched in 1985, providing a graphical user interface that made computers accessible to the general public. And Windows 95 in 1995 was a game changer. It introduced the start menu and taskbar that are still fundamental today.
It's amazing how some of those design elements from the 90s are still with us.
Right? And according to the research, the 1980s and 1990s saw widespread adoption of personal computers worldwide. The user-friendly GUI introduced by Apple Macintosh and Microsoft Windows made computers intuitive for a broader audience.
But computers were still isolated machines at this point, right? When did they start talking to each other?
That's where the 1990s internet revolution comes in. According to the research, the commercialization of the internet and World Wide Web became a global platform for communication, information sharing, and e-commerce.
And that completely changed what computers could do?
Totally transformed them. The Computer History Museum notes that the first internet users were UCLA, Stanford Research Institute, UC Santa Barbara, and University of Utah, connected on ARPANET in 1969. But it took until the 1990s for it to become mainstream.
So we went from isolated calculating machines to this global network of connected devices.
And here's what's really striking. According to the Computer History Museum, more than 1 trillion bits of data can now fit in an area the size of a postage stamp with modern magnetic storage techniques. Compare that to the first hard drive in 1956.
What was that first hard drive like?
According to Clemson University research, it had a capacity of 5 megabytes and weighed 550 pounds. Today's hard drives weigh a couple of ounces to a couple of pounds. The contrast is just mind-blowing.
550 pounds for 5 megabyte. That really puts things in perspective.
And according to the American Journal of Artificial Intelligence and Computing, we're now seeing the emergence of AI and machine learning revolutionizing automation, data analysis, and decision-making processes across healthcare, finance, education, and entertainment.
So we've gone from mechanical calculators to artificial intelligence in less than 200 years?
It's incredible when you think about it. And according to the research, we're also seeing emerging trends like quantum computing and edge computing that could be the next major breakthroughs.
What strikes me is how each breakthrough built on the previous ones. Like, without the transistor, we couldn't have had microprocessors.
Exactly. And according to Paul Edwards' research from the University of Michigan, computers are among the half-dozen most important post-WU technologies, fundamentally altering warfare, communications, science, offices, factories, and government.
It really has transformed every aspect of society.
And here's what I find fascinating. According to the research, each milestone reflects the social conditions and intellectual currents of its time. The evolution wasn't just technological, it was deeply human.
That's such an important point. These weren't just random inventions. They were responses to real human needs and problems.
Right. From merchants needing better calculation tools in the 1570s, to military needs during World War II, to personal productivity in the 1980s. Each breakthrough solved a pressing human problem.
And now we're dealing with challenges around AI ethics, privacy, and job displacement that will probably drive the next wave of innovations.
Absolutely. According to the American Journal research, we're grappling with ethical concerns like privacy, algorithmic bias, and environmental impact. These challenges will shape where computing goes next.
So when you step back from all this, what's the big picture here? What does this incredible journey from abacus to AI really tell us?
I think it shows that computing isn't just about technology, it's about human ingenuity and our relentless drive to solve problems. Every breakthrough we discussed came from someone saying, there has to be a better way.
And understanding this history helps us see that the technology we take for granted today represents centuries of accumulated human knowledge and innovation.
Exactly. When you realize that your smartphone contains concepts that Charles Babbage dreamed up in 1837, it gives you a whole new appreciation for both the technology and the visionaries who imagined it.
And it reminds us that today's impossible-seeming technologies might be tomorrow's everyday tools, just like those 700-pound room-sized computers led to the device in your pocket.
That's the real lesson here. The history of computers shows us that human creativity and determination can turn the most ambitious dreams into reality, given enough time and the right social conditions.